All right, welcome to episode 18. We are moving straight to how we can find the standard deviation, variance, and the mean deviation from what? A frequency distribution table. And in the episode 6 or 7, we discussed how to find the mean, the mode, the mean, and the median from the same frequency distribution table. We are just picking it from there. Now, from episode number 8, we talk about standard deviation, and we use SD as the root of sigma x squared over n minus the mean square. All these under the root. This is what we did for ungroup data. That is, if you're given the limited number of data sets. This is what we have for standard deviation. So that is if I'm giving values as 4, 3, 4, let's say 2, 4, 3. If I'm giving something like this. In finding standard deviation, what we learn is that we first find the mean. If you like, we find the mean, or we have our x values. Picking from the smallest will be 2, 3, 3. We have 4, 4, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we square it, the square of that. That means 4. This means 9, 9, 16, 16, 16. Now, if you look at this carefully, we can see that this is appearing twice. This is also appearing what? 3 times. So, in the previous episode, we are only going to say that standard deviation equals to the root of the summation of the x squared, adding of all of this. Let's see, if I add all of this, it will be 30, 48. So I have 48. This is going to be 18, right? And this is going to be 4. So I add 2 here, 20, remaining 2 here, 50, making it what? 70. That means I have 70 divided by the number of data I have is what? 6 minus the mean. What is the mean? The addition of all these numbers divided by themselves. So this will give you 1, 2, 3. That will be 12. Okay, let's say this is going to be 10, 18, 20. So I have 20 divided by 6, all squared. All right, my concern is not about getting the answers, but how we get to this place. We can see that we were adding this. We were repeating the 3, 3, repeating the 4, 4, whereby we can just go by saying x values. In here, I have 2, I have 3, I have 4. Let's go for frequency. I have 1. The 2 is appearing only 1. The 3 is appearing what? 2 times. The 4 is appearing what? 3 times. So if I go to the next one, which is going to be x squared. If I square this, I should be having 4. If you square this, 9. If I square 9, I have what? 16. If you check carefully, I am having only 1 16 and I'm having 3 of them. Do you see that? So in the case of this, I have only 1 16, which there are 3 of them. So in order to get that, I need to multiply this by this, meaning the f times what? X squared. You can see, if I multiply this by this, I get a value as what? 48. If I multiply this by this, I get 18. 1 times 4, I have 4. If you add this, just like we added here, you get 70. So instead of repeating the numbers, in some questions, the numbers are going to be repeating up to, let's say, 5 times. Some even have up to 11. So it means that you'll be repeating every number that you see. And if there are about 40 of them, You cannot list all these numbers 40, but you can list them, those that appear, and indicate the number of times they appear as a frequency to give you this. So the sum of what you are seeing here is going to be sigma fx squared. All of these, if I add, I get what? 70. So instead of putting sigma x squared here, I'm going to put the standard deviation is going to be the root of sigma fx squared divided by the sigma f. Why sigma f? Sigma f here, total frequency, 6. Number of items. The number of items I listed, 1, 2, 3, 4, 5, 6. I've listed 6. But in this case, in terms of appearance, the sigma f is going to be what? 6. Then minus the mean, which we also learned from previous episode to be sigma f over what? Sigma fx over sigma f, all squared. We are squaring that. Now, sigma fx, where is it? Meaning this times this. This times this will give us what? 2. This times this. 6. This times this. I think this will give us 12, right? So if I add this, I have what? 8. 8 plus 12. That's 20. You can see it here. So 20 will be here. Fx will still be 6. So if we are dealing with a frequency distribution table, the standard deviation formula is going to be quoted like this. I think sometimes when we are saying that there are so many formulas, which one am I going to use? This is used for when we are having a repetition of the data set. You can use this formula when the numbers are not repeating that much. I think in the episode 7 I explained when your data set is about up to 10, maximum 10, you can be able to use this one. So this is for finding the standard deviation from frequency distribution table. I guess this is clear. All right. Then if you are asked to find variance, the variance is going to be the sigma fx squared over sigma f minus sigma fx over sigma f, all squared. The square, if you square a standard deviation, you get a variance. If you find the square root of a variance, you find standard deviation. It's the same calculation. I guess we are good on this. All right. We are just trying to show how the formula, the difference between the formulas that we are going to be making use of. Okay. From episode number 8 again, we remember our mean deviation is given by the arithmetic mean of the absolute deviation. So sigma absolute bar x minus what? This. Absolute of that divided by what? N. So we want to use the same thing. Remember what we do. We just find the mean. What mean do we have in the first place? I think our mean was 20 divided by 6, isn't it? 1, 2, 3, 4, 5, 6. If you add all of this is 6, 10, 20. So that is this. 2 go here, 3. 2 go here, what? 10. 10 over what? 3. I think this will be 3.3. Let's just pick it to be 3 as a whole number. For the tutorial sake, I am picking it as a whole number. Okay, so let's generate a table. Let's send it here. We have, okay, let me leave the x here. I have x minus what? The mean. Let me go for that table. Meaning that this value minus 3. Let me cap it here. That will give you 1. This minus 3 will give you 0. Minus 3, 1. Negative 1. 1, 0. Then absolute bar of this. Remember the tutorial from 7, episode 8. we are picking this number if it are negative. So 1 0 1 1 1 what 0. So sigma x minus x bar absolute, meaning we are adding all of this. 1 2 3 4. So we have 4. That is the values we have. Now we can check that if I have the sigma x, okay, let's have the x here. We have 2 3 4. These are the numbers that are appearing from the data given to us. 2 3 4. So in finding their values, we can see the difference here will be -1 0 and 1. But I can see by frequency sake that this is appearing only once. The 3 appear what? 2 times. The 4 appear what? 3 times. So if I am to introduce all of this to find the total sum, it means that I need to multiply this by this. So work with me. Let's go through. We are only deriving the formula. So follow through with me. The absolute value is 1 0 1. So for me to find the summation of this, I need to know how many times this 1 is appearing. That is 3 times, right? So this is going to be added 1 times. This will be added 2 times. This will be added 3 times. That means the frequency will now what? Multiply x minus this. So this times this 1 times this 0 times this will give you 3. So sigma f times this minus this will be giving you 4. Just like we are having here. The answer will be the same. But we are doing this in the case that we are dealing with a frequency table that have frequency indicated. So your mean deviation will just be sigma f absolute bar of x minus what? The mean divided by what? The total number, where it will be f sigma f. This plus this is what? 6. And that will give us sigma what? F. I'm sure you get a concept of what we are doing. We have done this formula in episode 8. The formula before episode 8. But in some questions, using this become problematic, very difficult to use. Because there will be a repetition of numbers. Some number will be occurring more than once. Meaning we need to introduce frequency. If you introduce the frequency, you can't use this formula to find the mean deviation, because we need to use the f. We need to multiply that value. So you have the absolute bar, you multiply it by the frequency, find the total of that divided by what? The frequency. Just like we are adding all of them divided by this. I'm sure you grab the concept of what we are trying to do. So if I'm to find the answer, this will have given me 4 divided by what? 6, which is 2 divided by 3. That will be 0.6666, so 7. That would have been the mean deviation. This is how far each data point deviated from the mean. All right. Now I would not like to make the episode that long. We are almost approaching 20 minutes. So we are going to pick questions that will demand us to use these two formulas, not directly in the same episode, but maybe in episode 19, we pick that one of the standard deviation, 20 that of mean deviation, and see how we can apply this in solving questions. Share this video, like the video, comment, and subscribe.